We're here, Derek.
Oh, perfect timing, Tim. So I just started the recording. So welcome to the October 9th SIG Node meeting. Two topics on today's agenda. I think, Marcus, you were up first to talk through the node feature discovery repo transfer. So feel free to take the floor.
Thank you. So I'm Markus Lehtonen from Intel. I've been lately, for the past few months, taking over the maintainership of node feature discovery. And as we know, the Kubernetes incubator process has been deprecated, and we were thinking that maybe the project should and could be moved out from the incubator, and the Kubernetes SIG organization looks like a logical home for that. We discussed this shortly in June in SIG Node meeting, and I guess there was kind of or the opinion seemed to be inclined towards this being okay, so moving under Kubernetes SIG organization at some time frame. And now I brought this topic again on the table. I already created an issue in GitHub Kubernetes incubator repository about the possible move, and I tried to capture their like checklist, what things to do, some questions to answer, and a task list of things to do. So basically, I'm here to get feedback, opinions, advice on this topic. What people think about the move. Is there something missing? Some more data to be presented, more information to be presented. What would be required to accomplish the move, if so decided? So
I guess I'll share my perspective on this first. So I personally prefer that we take all sub-projects that are sponsored by SIG Node that we want to continue to sponsor and move them under Kubernetes SIGs where that's appropriate and out of incubator, just from a sane project discovery standpoint. So I have no objections to doing this. I'm not aware of any other immediate objections from folks. And so if it's just a matter of the process, Don's not here to act as well, but basically the process is we need to get the issue opened in the appropriate repo to execute the transfer, and then Don and myself should be able to act and okay on this, and then it can just get done. So, I guess that's my perspective on this. I don't have any major concerns on moving.
Oh, thanks.
So we recently did this with a couple other projects. So feel free you can follow up with me on Slack, and I can walk you through the steps one needs to follow. And then I think Don's out there mainly this week, but we'll just get both our acts on the issue and it should be fine.
Well, yeah, sounds good.
Okay.
Thank you. Any other comments? So yeah, we can continue this on Slack, and then the issue in or GitHub issue in node feature discovery repository. So checklist.
Okay, cool. For the second topic, Tim, do you want to walk through your runtime class scheduling doc?
Yep. Are we asking it? Yep. All right, let me just pull that up here. One more time.
Computer.
Um,
Do you want me to share it?
yeah, maybe I've been having trouble sharing stuff with Zoom.
You can just sit where I'm sitting. I don't know how it's going to work. Sharing things. Hangouts.
Yeah, maybe I'll just talk through it. And there's a link in the agenda if folks want to kind of follow along. Sorry about that. I think my window manager is not getting along well with Zoom. Actually, let me just try one more thing. I'm already out of the meeting. Okay, never mind. This is talking about scheduling with runtime class. This is a feature that we discussed when the runtime class KEP was still going out as something we want to address in the future. Now it is the future, and I'd like to address it. So this is talking about the case where you have a cluster where your nodes are not all the same. And you might have nodes that support different subsets of the runtime classes that are available in the cluster. And ideally, the user experience would look something like, I create a pod or a workload or replica set, something like that. And I specify I want runtime class foo, and that's all I need to do. And then when my pods are run, they're automatically scheduled to nodes that support runtime class foo. And if there aren't any nodes, they're held in the pending state. So there's a bunch of different ways that we could go about doing this. And I was trying to kind of capture all those different possibilities in this document. And then sort of from there, we can pick the best one, and I can move forward with that and write up a more formal KEP. Yeah, in terms of the goals, I already mentioned the primary goal is to be able to have pods run on nodes that support the runtime class. But there's some other features that we've talked about adding to runtime class, and I want to make sure that the solution we land on scales to the future state when those features are supported as well. The first one I thought was worth mentioning is pod overhead, which is the idea of setting some additional resources, allocating some additional resources for the pod based on the runtime class. So this is particularly useful in runtime classes like Kata containers, where your pod is a full, trimmed down and very light VM, but it's still a VM and it still has a relatively large memory footprint compared to native containers. And so that's kind of one example of where pod overhead becomes useful. And this becomes important in the context of scheduling because now there's sort of the circular dependency of, well, I guess you need to take that piece into account when scheduling the pod as well. But actually the circular dependency, the kind of complicating piece doesn't come until the next one, which is when rather than saying this is the specific runtime class that the pod is going to run with, this is a set, or some sort of selector, or there are multiple runtime classes that could actually be picked to run the pod. And this is something that we talked about in the context of this idea of fitting runtime classes to pods based on some requested features. So for instance, instead of saying I want to run with the runtime class Kata containers, I would say I want to run with a sandboxed runtime that supports GPUs. And then the system would automatically match that to the right runtime class. And there could be multiple matchings there as well. This could also be useful for rollouts. So say I'm rolling out a new version of Kata containers. I don't care as the developer which version my pod ends up running with. But maybe the new version, they've made some improvements to the memory footprint, and so it has a different pod overhead. And so that's where it gets pretty complicated thinking about the schedule. I'm not trying to solve this problem right now, but I would like to kind of think about whether a solution is going to be possible with the scheduling approach that we take. Getting into the requirements, there needs to be a mechanism in the scheduler to ensure that pods are steered to appropriate nodes. So this is basically, what does the scheduler do to actually steer the pods? There needs to be some sort of either discovery or registration mechanism so that you say, these are the runtime classes that this node supports, or the node itself says, these are the runtime classes that I know I support. And then the last piece is basically the API of how the node actually declares which runtime classes it supports. So going into that first requirement around what the scheduling mechanism could look like, there's really two approaches that I came up with. And I'm not an expert in Kubernetes scheduling, so I definitely may have missed some other possibilities, and this is kind of where I'm looking to get some feedback. The first approach would be to basically not make any changes to the scheduler and instead rely on the existing scheduling primitives. So node affinity would probably be the main one here. And what this could look like is the runtime class itself specifies, the runtime class API object specifies the node affinity for the nodes that support that runtime class. And then we would have a runtime class admission controller that basically takes that node affinity and injects it into the pod. So then when that pod goes to be scheduled, it already has the right affinity to land on the right nodes. The advantages of this approach are there aren't any scheduler changes required. It's fairly, non-invasive change to the system, but it would be very hard to mix this in with choosing runtime classes based on what's available in the cluster. In the case when we support multiple. Also, if the user has additionally specified some node affinities to select some subset of the nodes that support that runtime class, then mixing those node affinities together gets fairly hairy. And then also debugging, the debugging experience is potentially a little less user-friendly because you're dealing with abstract terms. You can't give a concrete error message like, oh, this pod didn't schedule because there are no nodes available that support the runtime class you've requested. Instead, it would look something like, no nodes match selector with this label set that you've specified. And so the other approach is just to modify the scheduler itself. The scheduler has a pretty modular architecture. And so these new scheduling predicates are sort of kind of a standalone thing. And in this case, we would basically write a scheduler predicate so that the scheduler actually understands the runtime class primitive. And basically, it would probably it'd probably have a runtime class informer, so it knows how to look up the correct runtime class based on the runtime class the pod is using, and then have some way of matching those to the available sets of nodes. This is a more native experience, more extensible as the runtime class feature set expands. Excuse me. The downside is that it's a more invasive change to the scheduler. But if that's something that the scheduling SIG is okay with, then maybe that's a non-issue.
Someone has something in the chat.
Oh, hey, I think oh, that's you presenting, sorry.
Yeah.
Chat.
So just for my own clarification on this, Tim, I'm sorry. Basically, option 1B says that the scheduler now watches runtime classes versus just watching nodes.
Sorry, can you repeat the question?
That might be confusing topics for. I'm thinking the list of resources that a scheduler must watch. With 1B, we're saying the scheduler must watch the runtime class resource as well. And then later on, you have an option, I think 2C or something, where a node is not necessarily reporting the runtime class on its status, but instead it's driven by some label selector. We're basically saying scheduler would need to be aware of how runtime classes are mapped to nodes and would have to start watching runtime classes.
Yeah, so in this one, it would definitely be watching runtime classes. I expect the number of runtime classes to be relatively small.
Yep.
And not scale with the number of nodes. So hopefully that's not too much of an issue, but that's correct.
Okay.
Sorry that the document wasn't marked public. It should be available now. So are there any other questions or comments on the scheduler side of things before we move on? Okay, so I'll talk about discovery and registration now. It's really discovery or registration, and or, I guess. But this is basically how is it determined what runtime classes a node supports? The first option I listed is based on runtime handler discovery. Right now, the only piece of the runtime class that is tied to the actual node is the runtime handler, which is interpreted by the CRI implementation to actually run the pod with the correct runtime. With the correct runtime. And so this is really the only information that the node has to say whether a runtime class is supported. And what this would kind of look like in implementation is some way for the CRI implementation to report back to the node the set of runtime handlers that were configured or supported by that CRI, and then the node could either broadcast, hey, here's the handlers that I support, or the node could be responsible for cross-referencing those handlers with the runtimes in the cluster, and then kind of declaring these are the runtime classes that I support. So the advantage of this is it's automatic. The cluster administrator doesn't need to do anything. You just configure your nodes with the right handlers, and they figure out the rest. Downside is CRI implementations need to be updated with a new API. And it implies that runtime handler is the only kind of meaningful piece of a runtime class that a node needs to support. So this means that if you say we're doing a rollout of a new runtime version, you would need to make sure that the new versions were had a different runtime handler name. Or say you say we started including devices into the runtime class definition, then that would need to be taken into account as well. There's not really any opportunity for the user, or sorry, the cluster admin to say, well, yes, this node supports this runtime class, but actually I don't want pods of this runtime class running on here, so I want to update the set. But potentially we could mix in one of the manual options. So the first manual option is basically to add a list of runtime classes to either the node spec or status. I'm not sure where it would make more sense. But say, this is the list of runtime classes that the node supports, and the cluster admin or automated provisioner or whoever kind of creates the nodes would be responsible for populating that list. Yeah, that's a pretty straightforward approach, but maybe a little harder to manage. Because you have to update every node every time a new runtime class is created. So the third option is to, rather than declaring the set of runtime classes that each node supports, rather declare the set of nodes that support each runtime class. So rather than updating the node spec, update the runtime class spec to include the nodes that support that runtime class. Yeah, I think this approach maybe scales a little better, especially if we go with kind of the label selector approach that I'll talk about later. Probably we don't want to actually have a list of nodes in the runtime class spec.
So one question on this one, are you assuming like that this would just be a label selector over like a role label on the node itself? Like is there a well-defined label that exists today that you'd imagine this select, or is that a different question?
I wasn't envisioning that we would have a well-defined label. I was kind of thinking more the runtime class has a label selector for nodes, and it could even look a lot like node affinity or just B node affinity. And then it's up to the cluster provisioner to declare the labels on the right sets of nodes.
Okay.
That runtime class. It could be that you have runtime class.node.k8s.io/runc/kata, whatever. But I'd rather, I think, leave it open-ended and just provide some guidelines for that.
Okay.
And so the last section is just about the API, which I think the API really falls out from the decisions made in the previous two sections, so there's not a whole lot to analyze here. But the different ways of reporting the runtime class supported by the nodes or nodes supported by the runtime class. First one is to just rely on node labels, which I think is my preferred approach. And then the other ones are explicitly list the supported runtime classes or runtime handlers on the nodes. Yeah, so that's all I came up with. After chatting with Bobby a bit, who, if you don't know him, he's one of the SIG scheduling leads. I'm sort of leaning towards implementing the native scheduler support, and then specifying a label selector on the runtime class that matches that runtime class to nodes, and leveraging that information in the scheduler plugin. So yeah, any thoughts on that?
I prefer, I'm also +1 on the runtime class label selects nodes option.
It's interesting. So we're essentially adding another place to put node selector labels. Like, could I, for example, decide to select on labels unrelated to the runtime class in my runtime class specification?
Yes, but except that I'm not really sure what unrelated to the runtime class means if you're selecting on them.
Right. I mean, I could, for example,
suppose you labeled your nodes into sets A, B, and C, and
like
just
like based on location, for example.
Yeah, based on location. And it just so happened that all of your Kata container runtimes were in zone B. I guess there is a concern that you could say, well, actually, I'm going to have 3 different runtime classes. They all use run C, native containers. And one runs in zone A, one runs in zone B, and one runs in zone C. And then you're kind of abusing runtime class as a new scheduler primitive.
I guess, and we can follow up offline if this isn't a simple answer, but I'm trying to figure out what you gain by having another place to put label selectors.
As opposed to putting them on the pod
As opposed
itself.
to just like, if I'm a user, right, you're saying I write a label selector inside my runtime class. Is that to you better than just writing a label selector or a node affinity in my pod spec in the node affinity section?
Yeah, so the advantage I see to this is the user who's creating the pod spec is probably the like the application developer.
There's a level of indirection.
They care about they might care about which runtime they're using, but they don't necessarily care about which set of nodes they're scheduling to. Versus the runtime class is configured by the cluster administrator. And so they're the ones who say, okay, this set of nodes is going to support this runtime class.
So the one question or thought, or maybe you thought about, Tim, was how would I ask this? So if I wanted to understand why a pod was scheduled where it was scheduled, do you see that the label selector clause that's on the runtime class associated with that pod gets merged with the pod's node selector? Or do I need to do a different level of analysis to understand why the pod landed where it landed?
So that's kind of getting into the first section of the scheduling mechanism. What I called option 1A is basically merging that label selector into the pod. And then 1B is saying that the scheduler would sort of resolve that behind the scenes and the pod spec wouldn't actually change.
And I think you said you preferred 1B over 1A?
Yeah. I need to maybe work through some actual examples, but I think that if the user like if someone else has specified some node affinities, then merging those with the runtime class ones can get a little complicated.
I have another question. Is the idea that I can select multiple properties of my runtime class? Like, for example, if I wanted to run separate like selectors in my runtime class?
So that's a different problem. That's
okay.
What I mentioned as like one of the future directions that we might want to go in is selecting the runtime class from the pod.
I see. So for now, I'm just explicitly selecting a runtime class.
Yeah.
Okay.
But that is one of the reasons that I prefer the native scheduler support.
Okay.
Is that suppose I say that I want to run my pod with Kata containers, and we support Kata 111 and 112, and 111 has an overhead of 50 megabytes and 112 has an overhead of 40 megabytes. If we went with merging the runtime class affinity into the pod spec, then you could imagine having some complicated logic where it says, this pod can run on the superset of the nodes supporting Kata 111 and Kata 112. But then you still need to kind of resolve the two different options of pod overhead in there, which might be pretty complicated in the native scheduler support as well. And so we might want to make some simplifying assumptions there.
I was also trying to think about reporting of node features, because if let's say I support Kata 111 and like some other runtime 112, and then I ask for Kata 112, is it going to be able to figure out that there's a certain grouping of labels for each runtime class? Or I suppose maybe that's a little bit further than this goes. Essentially, it seems like we have a single namespace for describing node features, and that how would I describe that one doesn't support GPUs and the other does?
Yeah, so I think that's getting a little more into the kind of feature of how do you select runtime classes from the pods. But yeah, it could be, there's a number of different ways that could look like.
So how is the pod overhead going to be used? I mean, once we have that, actually the regular scheduler should also be aware of that, right?
Yeah, so
then why we still need another scheduler to understand it? I don't.
So that
I mean, the original scheduler, when schedule a pod, it should consider how much the overhead and what's the request and limit, and then make a decision, right? Then if that's the case, why do we still need it?
So that actually has a similar kind of question of, do you merge it into the pod spec, or do you teach the scheduler to understand runtime classes? Where suppose the runtime class says this is the overhead for the pod. You could have a pod overhead field on the pod, and then the admission controller basically says, okay, you're using this runtime class, then your overhead is this, and the scheduler understands that overhead field on the pod. Or alternatively, the scheduler knows how to look up the runtime class from the pod and then look at the overhead specified in the class from there.
So I'm less convinced on the 1B choice over 1A. And I like the idea in theory that I can look at a pod and understand why it was bound to a node without having to look at additional resources, I guess. And especially because in the case of runtime class, if I'm not mistaken, Tim, that mostly everything on there was immutable post creation. That the overhead cost is fixed. I can't think of a good reason why what benefit I get with the indirection, I guess, versus the major pro I have is what you're basically positioning runtime classes for here is similar to what we position other things, say in OpenShift R, is a way of guiding pods to the right pool of nodes. So whether that's a namespace scope node selector or it's a runtime class based node selector, it's just yet another thing that merges into your node selection set. And to me, that seems easy to understand. I don't know, for some reason, that's just the idea of having to get a third resource to understand and how to schedule the pod. I'm less convinced on, but maybe Bobby has good reasons.
I'll take an action item to write up a couple examples of what it would actually look like to merge in some node selectors. Because I'm worried that it would get, the logic on there would get very complicated or even be impossible to merge in, but I'm not sure. I'll need to work through the example.
Yeah, I mean, I know we have other admission controllers in the open source Kubernetes as well as downstream, distributions that do that. And so at least I have a sense of what that looks like. But maybe there's something unique I'm missing here that maybe your example could call out.
Yeah, sure. I wasn't really thinking about the use case of kind of like the positive feedback of the node is the pod is actually scheduled, and you want to know why it was scheduled to that node, versus I was thinking more about the case where the pod is not scheduled, and you want to know why it's not scheduled. In that case, I think if you're just merging in the node selectors, then you could end up with a very complicated error message that says, well, nothing in this label set matched, and nothing in this label set matched, and nothing in this label set matched, versus if it was just natively understanding the runtime classes, you could just say, no nodes are available for runtime class foo.
Yeah, I guess that could be a trade-off. I mean, I'm not sure if that is worth it, though, I guess. Because there's a variety of reasons people's pods don't schedule.
Yeah. And I guess if you are then mixing runtime classes with, other scheduler primitives, then you still need to say, well, there weren't any nodes available that supported runtime class foo and had these labels and didn't have these taints or something like that.
So what happens if I have a cluster autoscaler trying to scale up a machine to run this pod that can't be scheduled? Does having to make the scheduler aware of these things also then require me to make the cluster autoscaler aware of these things?
That's a great question that I hadn't thought about. So yeah, I'll need to go back and look at what the autoscheduler, makes its decisions based on, and whether one of these approaches would be easier to implement there.
And then I'm still thinking about pod overhead and that type of thought as it relates to like anything we do in a vertical pod autoscaler. And so I don't know the intersection between runtime class selection and dynamic pod overhead selection as it would then potentially map to like how a VPA would assign resources, but I don't know. I agree with the other choices you make at first when reading this, and but I'm not sure on just option 1A versus B.
Yeah, okay.
All right, well, I think that was the 2 items on today's agenda. I guess to close out the topic, David, I'm going to review the device proposal right when I get off the phone here, but are there other people's PRs that need attention that are not getting attention and want to call them out now?
Yeah, this is Robert Crowitz. Just like to know what next steps I need to take with the ephemeral storage quota project.
Okay. Yeah, so I know you have that document open as well, Robert, so we'll try to get eyes on that. And then
so I also have a PR there that people wouldn't mind people wanting to start looking at the code too.
Okay. Any other topics that people want to bring up today? All right. Well, thanks everyone, and thanks to those who presented, and I'll talk to you later.
Thanks, Derek. Bye, everyone.